welcome to Mempathy, Alignment of Language Agents for Serious Video Games. I'm Gema. Today I'm going to speak about large language models and its implementation in video games. And I would like to thank Data Innovation Summit this year for allowing me to give this talk. So what is Mempathy? Mempathy is like a point-and-click narrative experience to transform the relationship with anxiety and discover something about yourself. It can be defined as a conversation in the stars, in which we make several options, clicking words, and take several paths to actually have a reflective experience that can help us advance. It is based on watercolor design, using words, using edges, and mostly of all, it aims to create a calm, relaxed experience to discover something about yourself. It is based on three main principles that they are supported by both the gameplay and game by itself. The first one is progress. This idea of progress is supported in art by watercolor progression across the different chapters of the game. The second principle is companionship, as the NPC, or the artificial intelligence agent, is constructed with machine learning and develops itself under the principles of personhood unbounded, being able to respond to the player using the same mechanics as the player does. The third principle is choice. The player takes different choices in order to decide how the conversation might evolve. So in the end, for resuming in one sentence, we could say that Mempathy is a conversation. Regarding the NPC of this conversation with the agent in the start, we want to dig into the research question of how do we create agents that behave accordingly to the designer's intention. This question is posted in the Alignment Forum by Cristiano et al. And has been a research question posted for a while. Here in the video game, we explore 2 points to answer this question. First one, the game mechanics, and second one, the content generation. Building a game is an iterative process, and building an NPC using artificial intelligence, so it is. The previous explorations about this project have led us to use reinforcement learning and imitation learning in video games and have been published in several conferences such as ADE and NeurIPS. So going back to this research question about alignment, we're going to explore first how the game mechanics make an influence on the gameplay. We must say that these constellations are based or inspired in graph neural networks. Having that into account, we take the elements of graph neural networks and we use them to produce a conversation. As the first one, we have the node that it represents words. In the second, we have the edges that it could be understood as sentences. And in the end, we have this network that overall can be understood as a conversation. So how does this game mechanic Mempathy work? So in the terms of constellation, we have a scene, the first scene, constellation A, in which an hypothesis is posted and the player go through clicking in the words and discovering one topic that we might want to explore. And then we get into a divergence in the narrative. One can be a confirmation of the narrative and another one can be the denial. Then the artificial intelligence agent in scene 2 produces 2 different kind of content that are consistent with this first constellation, and then the human must choose which path they might want to use. So the first one, we have this kind of confirmation of denial in the narrative, plus the content generation by the agent. In the second one, we have a more open-ended scenario in which this player is yet producing through this clicking on the nodes And the agent then divert into two options that can be an adverb, mostly adverbs and adjectives. And then like the player can choose which narrative they want to direct to. In constellation C, we have like kind of like all these joint conversations of kind of like choices together to produce an overall conclusion of the conversation. Besides the constellations, we have like the skeletons. The skeletons are these like substructures that like make us combine these kind of like constellations, producing like different things. So there are like several choices in which like the human must be following the conversation and taking several paths. And then these paths are going to be joined by themselves, taking another options. In these skeletons, there is also always like a first introduction in which we present like a topic, and then we can combine these kind of like skeletons to produce like the combination or denial of the narrative. Then we can have like a follow-up hypothesis, and then like the conclusion. This can be interchanged and actually produce like an anytime unique conversation that is like provoked by both the choices and the combination of the skeletons. So besides these game mechanics that like overall the conclusion is that they allow us like kind of like to control these dialogue structures, we also have like a main challenge to overcome, that is like the content generation. It's like how the agent is going to respond to the player in order for the player to take better choices. For this, we have been doing like several research, as we said before, with like reinforcement learning and imitation learning, and like the best, the most consistent and robust results, therefore, have been for scaling kind of like this proposal and using like GPT models, large language model, for actually producing content. However, large language models have its own challenges, and there is like this aim to control or to align the NPC or the agent motivations with like the content generated. For that, we implemented a paper by AI called Plug and Play Language Models. There is like approach to control text generation. So we could understand kind of like this GPT model as a giant whale train in the internet, right? And these like plug and play models, what it does is kind of like it shapes, it makes a discriminator on top that shapes kind of like the gradients and produces like, together with this attribute model, that we will see, what it does is it's control the generation consistently to produce the type of content that we would like to explore. So let's see what it's like these plug and play models more in detail. So there are like three main key ideas from plug and play models. The first one is like the plug and play model is an top discriminator. It's not that we retrain GPT, right? It's that like we kind of like reshape like that content generation without retraining the model. For that, what we do is that we define what is called like an attribute model that like conditions like the probability distribution of the generation of like the next word, right? As large language models do, defined by a set of words. This set of words, this vocabulary that we kind of like tell like the agent that they should use is where offers this possibility to align the large language model with the motivation of the agent by their vocabulary and their motivation. However, there's like kind of like a key aspect here in the experiment definitions and hyperparameter search of these kind of models to actually produce like the most scalable results. So what we need to know here is that, like, okay, we have like this probability forward pass with the large language model, and in the last layer of that, we have like the attribute model that like recomputes the latents and the gradients of the model, and then it produces new content. So here, for example, like a GPT, a standard GPT model, it has like time is a moment, right? Using this attribute model, it like kind of like recomputes like this kind of like content generation in the last side, and we could see something like time is a gift, right? Changing the overall distribution of like the probability of the word and like the content. For that, as we have said, this attribute model is defined by two main parameters. One is like both, like the bag of words. This bag of words can be aligned with like the character, and a hyperparameter is called the strength factor. There's like how the strength or how hard is going to be this attribute model over the large language model. Having said that, for this experiment and well, for this solution, we haven't used GPT per se, but a fine-tuned GPT using Hugging Face Transformer with like CMU books summary. We have like make an exploration of like 300 samples generated for each constellation. In a total of like 24 experiments with different prefixes. And regarding this hyperparameter search for this strength factor, we have like get like kind of like from 0.1 to 0.001. So it's kind of like or the order of like 2 orders of magnitude. And we have like created two kind of like attribute models, one of like 2,000 words, and another one with short attribute model with like 200 words aligned with the agent's motivation. This means that like we made like a bag of words of like the vocabulary that the agent would use to respond in kind of like with 2,200. We have been kind of like benchmarking this GPT-2 model together with like these plug and play models with different hyperparameter search. And besides that, we explore kind of like also like the concepts of incoherence, the harmful or deceptive content that it could entail. So from a GPT-2 fine-tuned model over these like 300 samples, we kind of like observe that even though the GPT model was kind of like fine-tuned, there were like up to a 35% of like kind of like content that was like not suitable for the project, that like kind of like led us to a non-scalability issues. However, with like plug and play models in like different hyperparameter search, we have like kind of like reduced up to the half in incoherent and harmful, and almost up to 10x like the deceptive concept. Besides that, we have like kind of like also study how the narrative goes to kind of like a positive or negative, even though when it's like a denial or confirmation of a narrative. And actually using like these bag of words together with like a let's say optimistic vocabulary produce much more positive kind of like sentences, even though like there was like this denial of the narrative. This like kind of like shows us that even if the player chooses to deny the narrative, there might be kind of like a way of not getting into unhealthy conversational loops. Here we can see kind of like one of like the content generations in which we represent in black kind of like these notes with words that like the player is clicking, and in blue it's represented kind of like the content that it's created. So here, for example, we start talking about like time and about like never good enough and choices in life. And then here, like in the first option, the agent starts talking about like the need of courage to accept hard times with a smile. This entail us to learn from our mistakes and then to grow stronger. Actually, we can grow stronger even with hard times. Remember that in order to overcome any hard time, one has to learn of how to accept adversity with grace. And the grace is just not the grace of our own, but also others. And this, in the end, will give us strength. Here we see kind of like this thing that we talked. So the first two lines are the constellation A, and here we have like kind of like an acceptance of the narrative with like the premise of indeed. Then we follow this structure B that like kind of like expands that mental model or vector thought, and like the last but not least, we get into the conclusion. So large language models have this long-term sequence dependency kind of like challenge to overcome. And if we see that like in the third line, there is like the courage to accept hard times, right? And in the conclusion, it says that remember that in order to overcome hard times, so it's like able to bring that like sequence of words that was like using before. So creating in that sense, kind of like that consistency. In the second example, we have like absolutely the same prompt, and but it starts exploring other things. It says like, indeed, life is a great venture to live and to enjoy. This will entail a few choices in life, which is why we should try our best. Actually, we can try to help others because we are all one. Remember that this will give us the courage to have compassion from other people, to help others and ourselves, be generous, and we can give. So first generation goes more about like kind of like courage to have time and how to grow. And then the other one talks more about like kind of like life in general, compassion and relationship with ourselves and others. Here we have like another example, but that like talks about perfectionism. And yeah, I mean, here it's like kind of like in the first one, explore goals, explore what means to be successful, and kind of like that relationship with failure. And in the second one, it's like kind of like exploring other things, Salas like rewards and take time and patience to appreciate what like people is doing. So here to create this kind of experiments, that like had to be scalable and had to be at any time unique. So both like the game mechanics, this structure of the skeletons, and the content generation using a plug and play models were kind of like key for that. So if I wanted to take like one sentence from this kind of like project, many people have like approached to me and says like, oh, so you're doing things with like GPT. And it's like, okay, so in the end, this is not GPT. This is like a fine-tuned model GPT with plug-and-play models that are aligned, thanks to this discriminator, this attribute model from plug-and-play. And this alignment comes from the game design perspective, plus a huge hyperparameter search. You can find more. This is like one of like the publications made like in ICML as like kind of like a resume of this. And yeah, that's it. I'm happy to take any questions or any comments that you have. And please feel free to reach me out, Twitter, GitHub, LinkedIn, or wherever. Thank you so much for watching.